Welcome to lesson 2. We'll talk about designing a mean stack architecture, right? We'll go over again the mean stack and we'll talk more about the application and the architecture, right? We talked about the event loop wherein you have the client sending the request, right? It is single threaded, but it will be non blocking because it will send, um, it will not wait for other process to finish, right? Or other jobs to finish. It would send those to a worker thread, right? And then if it's done, then it goes back to the event loop, right? So it does not wait. It will process what's can be processed, right? So how do the component parts of the mean stack fit together, right? The mean stack architecture, the SPA, that's a typo, and multi-page application, right? So whenever you interact with your browser, you're called like a user, or the browser is the client. It's the interface. It's what you see, right? Whenever you wanna retrieve something, let's say from a page, from Facebook, Twitter, social media, or CDU even, right? You would communicate via HTTP, sorry, or HTTPS, right? And then through that HTTP request, it would request to the corresponding server, right? Because you put the address in the browser, right? So you would put a request to that address, and once it finds that address pertaining to a server in the cloud, aka the internet, right? And then the server would fulfill that request and gives back a response, right? And that's called an HTTP response. Okay. So a common mean stack architecture is you would have the REST API, representational state transfer API. Quick thing about REST API: these are guidelines. It's not something that uh, like you build. Like it's a guideline, right? So one of the things that you really have to remember about REST API, it should be stateless, and we'll be talking more about that. Okay, so let's say you are the user, right? You are seeing your the client, the browser, right? And you requested for something, right? And again, it will now communicate and request, right? In the REST API. The REST API, let's say it includes the backend and also there's a database, right? And it gives back a JSON, right? Oh, before that, going back. So when the client requests for something, it's gonna be in the form of the JSON, right? What can we request? Can we grab me a list of products, right? That request um, can be. Also, let's say you are doing a post request. A post request. Let's say you do a login, right? So you put the header, and it's gonna be in JSON as well, right? The payload, the data that you want them to send, right? Okay, so API, right, enables applications to talk to one another, right? In case of the web, API is normally a set of URLs that responds when the data is called in correct manner with the correct information, right? So with the API, it allows interaction between devices, servers, right? Applications, right? Uh, Another quick analogy for an API is, let's say you have a lemonade stand or whatever, right? You have an API, let's say the spout of your lemonade container, right? And you just don't give the whole lemonade juice to your customer, right? You have it in a container, right? Think of the lemonade as the data, right? And the spout is the one controlling the data flow or the lemonade juice, how much, how many, right? What to give. And then that's the one you give back to the requester. Could be a user, a customer, and an application. Okay. CRUD operations are in the database side. It's related to the HTTP request. Let's say a get would be meaning I want to get something. It's means reading, right? Um, and then if you wanna submit something, that could be a create, delete, or create or update, and you can also request for deletion, right? The CRUD is more on the database side, wherein you do a create statement, a read statement, an update statement, or delete statement. Okay, and those actions would definitely make changes to your database, right? Create means it creates a new document for NoSQL, right? Read, it means just retrieve the data, right? Update, it modifies the data, right? And delete, um, deletes the document. Okay, read is a read operation. Create, update, and deletes are write operations. Okay, so API as a service. So it shows here API is equals. That's a JavaScript equality operator, right? It means money, right? So nowadays, a lot of people are making money with APIs, right? Building APIs on top of APIs on top of APIs, right? Yeah. For example, if you have like a data about, just for example, let's say Star Wars, right? You have a lot of data about Star Wars. You can host that data, and then with an API, then you can have people, let's say, pay you to get access to those data, and they get it through an API, right? It means that you also have to structure your application so that they can request for that data instead of you just giving them a one big Word document or Excel file, right? So on the left hand side, you have the monolithic, wherein you have the UI, business logic, and data access layer stored in one machine, right, or one server. In microservice, you basically decouple them and make them separate for each type of service, right? When we say each type of service, instead of like the whole shopping experience in one monolithic server, you can have the shopping to be shopping cart in one microservice. You can have payments in one microservice. You have the checkout in one microservice. Okay. This also introduces us to the serverless computing, wherein it goes back to the cloud deployment model, where you now don't need to manage the infrastructure and even the platform, right? Um, this time around, you so when I said a while ago with Heroku platform as a service, right? You still need to deploy your code, right? With serverless computing, you can just write your code and run it, right? Um, and from left to right, we have, let's say, Amazon S3. Amazon S3 is basically a storage service, right? Where you can store files. You can think of it like Google Drive or Dropbox, right? But also, you can also put your front end files or code, right? And use that Amazon S3 bucket as a static website. Then you can um, render HTML to the requesters, right? So the user clicks the link from that HTML page, right? And then we have the Amazon API gateway. So the gateway helps makes REST API call to specific endpoints, right? Think of it, it's just routing, right? And let's say it interacts with our AWS Lambda. This is specific to AWS, where you can run code to retrieve local information or even respond to events, right? And if you're going full on Amazon, you can still use the Amazon DynamoDB, which is similar to MongoDB, right? So going back to REST, it's an architectural style rather than a strict protocol. So it means that there are some times that you may wanna skip some of these REST guidelines because you need it for your use case. That's fine, right? So REST is stateless, as I mentioned, is no has no idea of any current user state or history, right? What? So when you interact with your web browser, when you're thinking that there are times that you don't need to log in again, you see the same information again right away, right? So there has to be some state. Yes. So let's first tackle that part. So when you interact with that one, with the in the browser, you do get the front end portion, right? And the front end portion is stateful, right? It You can in the browser you can store the local session, the user session. A good example with that one, let's say for here, I can right click somewhere here. It doesn't let me. Let me go to, let's say, google.com, right? I can right click, inspect using the dev tools of Google Chrome, right? And you can see in the applications, you would have cookies stored. That's also state, the cache, local storage. You can access this, right? So those are the one that's keeping your state, right? That's why you have saved information. However, from the back end side, right, when we want to do a REST API architectural style, right? Let's say you requested for the a certain product, right? Um, so once it reaches the back end doesn't know if this certain user or certain application did it request it previously. Doesn't care, doesn't know. I'll just process it, right? So that's it being stateless, right? So, and because the rest is important, but I guess not for now. Sorry, because I think we have a whole lesson for that. So we can go ahead for now. CRUD operations. We can see that in the CRUD we have the respective SQL keywords, the HTTP methods, and then the database distribution service, right? Okay, RESTful API. So you have the base URI, uniform resource indicator per resource. So if we were saying products a while ago, you would have the slash products at the end instead of slash articles, right? A data structure usually JSON passed in the request body, right? Um, let's do it later, okay? The usage of standard HTTP methods, for example, get, post, put, and delete. REST API is stateless. Location, okay, okay, and okay. So these are example routes. As you can see, the get post has the same endpoint, but it has a different method. So it would require more stuff, right? If get request would just require nothing, a post request might require, well, which article do you want to see or want to create? I mean, want to modify, want to create. Okay, can I mean which a lot of articles, I guess, right? Get single, right? A post is also single, right? Put, delete, okay. Message exchange protocol, right? These are the older ones, like especially like SOAP. HTTP is now mostly, I mean, the standard, right? From protocol to representation, following the REST API guidelines. The external data representation (XML) is the older way we pass around data. JSON is now the standardly used, right? It's lightweight. We use AJAX calls and use SPAN multi-page application, right? So HTTP, the Hypertext protocol. So from the client, from the computer, let's say you have place a URL and you press enter. A browser sends a request message and you get that get URL HTTP 1.1 blah blah blah, and the server will process that and returns an HTTP response and shows that in the client, right? Let's see if we can quickly show a something like that. Let's say we want to let's say persona 5 whatever API whatever. um, let's see, let's start with the inspect, right? Let's see, let's click this fandom instead. That should be fine. Okay, when I click that, sorry, you should go to your dev tools and go um, application. Hold on, let me make this bigger. Not that one. Console. Yep. So you're seeing the get request from here, right? In the network part, and if I click one of it, let's say this one, right? Let's see. So vendor list, right? So as you can see, when you requested for a page, the page requested for several requests to the respective server, right? Um, let's see an easier configure app. This one recommendation, fandom article sponsored recommendation, right? Page info, right? Okay. As you can see, it's requesting different data and then doing a request get method with the status code, right? Response headers, this is what you get back, the metadata. Request header with just the path, right? So this is a way to inspect. Go to the right click inspect and then go to the network section. Okay. And then we go back. So designed to store and transfer data, but JSON is more popular. Yes, designed to be self-descriptive. This is just a FYI. This is an XML. HTML looks like this. And you can go to this resource or freecodecamp.org, so you can learn HTML and CSS as well. CSS helps you style the HTML, bring some colors. This is the hierarchical of the document object model. This is important if we do want to do some manipulations and use it in our JavaScript code, right? Knowing how to traverse this, right? So Ajax, asynchronous, that's the keyword, right? And XML. We still call it Ajax even though we're not really using XML, just because we are used to saying Ajax, right? Okay, and just try to pause and have a quick look in this diagram. But basically, what it does is you do an HTTP request and you get back a response, and there's an Ajax engine in between. Okay, it allows reloading of a component and not reloading of the whole page. Okay, so the HTML inherits from the XML, right? HTML DOM implements the HTML. Okay, HTML is associated with CSS for styling and JavaScript to do some add some functionality, right? Add some logic, right? Ajax has the dependency for JavaScript because that's asynchronous JavaScript XML. Um, JSON is also dependent on JavaScript because it's JavaScript object notation, and JSON is now being used to an external application. Okay, MPA versus SPA. Okay, this is a recap, right? Multi-page. I do a request, reload the page with the reload icon. SPA, I do a request, it's fine. Ajax would handle it and maybe just refresh that component, or maybe it doesn't require refresh for that submit, right? Okay, traditional, right? Uses MPA. We already said that it's better for search engine optimization because there's not a lot of added components or syntax there, right? Cons is complex to maintain, and your backend and front end is coupled, meaning there's no backend logic and front end view or front end logic. It's together. Single page application, um, smooth and fast, easier to debug, lower hosting costs. It's more lightweight, poor on search engine, right? Another reason why it's lightweight, right? Because you don't need to reload the whole page. You just reload a component, right? MPA, SPA. Technical approaches for SPA, we have the following: the usual suspects. So you have the user experience, the hosting cost, you have the disadvantage, crawlability, okay, SEO, analytics, page reload speed. Eh, Just to note that SPA loads slower at first, right, but it loads faster when it renders the required views. So, flexible mean architecture. Your MongoDB can store and stream binary information, good for real-time connection for Node.js. Express for web application with templating, routing, session management built in. So we're using a built-in tools, right? So let's say you have a blog engine. Mm-hmm. So you would have blog entries, right? And you also need to have an admin interface. If you worked with content management system before, it's similar with that, where you need a let's say a um, a component or a logic to do your blog entries and also to administer your content, right? Or your manage your access, things like that with admin interface. So admin interface using SPA, public interface using Express. Okay, and do your corresponding hands-on skill for this week. Public interface, Express plus Angular, a hybrid architecture, right? So here's what it helps, right? Now we see the bigger picture where it's decoupled, where if you want to create a page, right, for just blog entries, you can use Express, Node.js, and MongoDB, right? For admin, you can just use Angular, right? And just so you know that you can also use different stacks as long as you communicate JSON, you should be fine. Okay, integrated versus API approach, right? So in the integrated approach, you have the Angular application has the integration layer, communicates with the database, right? And then Node.js application and the database for the mobile app. There's another integration layer, right? If you do the API approach, you can just communicate with the API server, right? So as you can see, instead of each app having integration layer, you can now directly go to one source. Okay. Key to start is to iterate and improve until you're happy. That's use SDL, right? The agile approach, architecting the application. Okay. When we architect, we need to think about the system design and the scalability. Remember that. So with the application, here are some of the details for that app. Dividing the screens, collections, the first three screens, right? So this is where we think about how the user, what is the user flow, how would the user interact with the application, right? So there would, as a user, I should see that there should be a list with nearby places. Think about like Yelp, right? A screen that shows details about an individual place when a user clicks on that place, right? A screen for adding a review about the place, right? and about us. Okay, as you can see, you're doing some requirements gathering now where, so what are we going to build, right? So these are is could be these are iterations, so this is not yet the final product, right? We can say. And we start with the API application architecture options. So we do want to build our backend first, right? Build the logic, add some placeholder, right? And then configure your database and make sure your API server has a connection to your MongoDB using Mongoose, right? And communicate, right? Even before this one, you can just drop the database first, have your backend, and try to communicate with it. Do a GET request, right? You can use it with the curl command or the postman. So, full stack architecture looks like this. As I mentioned, that you can have many applications communicating to the API server. So these are our proposed architecture where you have the Express application communicating with the API and also Angular single page application communicating with the API. Okay, these are the technologies. Have to fix it now. It should be pug, right? And client-side technologies, backend technologies. Okay, and again the end product. So rapid prototype development, build a static site, right? Design your data model, create your DB, build your REST APIs, the um, meaning you build your routes for the GET requests, POST requests, right? Use the APIs from your application, right? So consume, I mean request and consume, and then you augment, improve. So in this book, we do go into until the authentication part, but we won't cover that part as it requires more time. Okay, so let's go over it and try to build your static site, scaffolding, data model, build your REST API. Okay, hook the Express application into the data API. Okay, ignore this Angular part first. It's grayed out. I know it's not that clear and it shouldn't be placed here for now, right? Okay. So in chapter 8, yeah, they integrated the Angular. Okay. Move on, and move on, right? So we'll talk about the hardware architecture where in the development environment in your CPU or you can just say your laptop, right? You can install a database, right? You can install the like Node.js and Angular, right? And you can basically have your REST API server exposed in one port, say port 3000 in your application in port 8080, right? And your database in let's say port 27017, right? And then they just live in one machine. A production environment, we can do something like this, where we can host it in your laptop. Again, this can be your laptop or it could be a cloud provider like AWS, Azure. You can host that. So in production environment, you may want to separate your database first, right? So you can either install a database in a server or most of the time now, like MongoDB, they do offer a service, so you can sign up and that's they have a big free tier there. So you can have MongoDB Atlas there, right? And communicate with the server. So this is what we would want, where the application sits in one server, the REST API sits in one server, and database sits in one server. This also helps us when a server goes down, not everything goes down. Okay, right? And we can do something like this, where we need more storage for databases, or it could be just for redundancy in case any server goes down. and we can reroute the traffic. Okay, so development versus production server. Now you can see this image first with the past. That's Heroku, right? And let's say on-site, you manage everything, infrastructure as a service. They manage the infrastructure. That includes until the virtualization part, right? The platform as a service. They manage until the OS runtime. So if you have infrastructure as a service, and you, let's say you use that service, you are responsible for updating your operating system. Platform as a service, you don't need to manage the operating system, right? Software as a service, no need to manage anything. You just use it. For example, your Google Drive, right? Your OneDrive, you just use it. Okay, summary. Application will be built with Express, right? Okay, that's it for this lesson. And let me know if you have question, please, regarding a textbook, lecture, anything. I'll be in MS Teams and Blackboard LMS. Thank you.